let's figure it out.
I'm gonna unscrew things in my backpack if I can find it.
I struggled with this problem for so long.
I'm not gonna give
You
my
were
laptop,
persevering?
So.
Yes, I did like 3 times.
Well, that's awesome. I know you don't see it as being awesome, and I get that, but to me, where'd you do that? Oh, it was a calculator. Point. All right, which one? 5.
I've fallen and I can't get up. Don't help me, I've fallen and I can't get up.
You okay?
Yeah, it was not actual falling.
So we are on. I was on the wrong page.
Say hi to the camera. Oh. Yeah, they got to see you. I said hi. Did you really?
Yay, got there. Cosine of 75. So after all that, it was just cosine of 75 degrees. Right? Now they ask us to use the half angle formula. So we want to do that. So basically, we want to say that this is the cosine of something over 2. Fair? What's the something?
It's depressing.
150 degrees.
You know what else is depressing?
What is alpha? Alpha is 150 degrees. Keep that in mind. Here we go. Cosine of 150 degrees over 2 is equal to plus or minus the square root of 1 plus the cosine of 150 degrees over 2, which is equal to plus or minus the square root of 1. So what is the cosine of 150 degrees? So this takes us back like a month, doesn't it? Reference angle, 30. Chart,
2.
square root of 3 over 2. Quadrant.
All students. So it's negative.
Why?
It's quadrant 2.
Quadrant 2?
Yeah.
Because we're finding the cosine of 150. So cosine of 150 is in quadrant 2, so that the cosine of it is going to be negative, so 1 minus root 3 over 2. Was that the issue or not?
It's like part of it. I'm just confused why on
Yep.
3 they don't put it in the problem to begin with. Because they, like,
Okay, let's talk about that in a minute. We'll crank this. So we're okay here? All right, now what? Times 2? Times 2, times 2, times 2, and then zap the 2's. Equals plus or minus the square root of 2 minus 3 over 4, which becomes plus or minus the square root of 2 minus root 3 over 2. Square root of the top, square root of the bottom. Anything we need to simplify? No, I like that. So the only thing we have left is plus or minus. Which one is it?
Quadrant.
What quadrant are we getting the cosine of? Yeah. We're looking for the answer to cosine of 75 degrees, correct? Cosine of 75 degrees, quadrant 1, which therefore is positive, and that should be our answer.
I understand now. I was confused why they used 165 for this. But that makes sense. The reference angle is okay, yes.
Cool, good. And as frustrating as it was for you, and I get it, but because of doing all of that, once we went through it, it made it easier, and so that was good. Good job. Next, 7. 7, tangent of 67.5 degrees. tangent of 67.5 degrees. We're going to write that as tangent of something over 2. Is that okay? What is alpha? Alpha is 135. Keep that in mind. All right, we have options. Option 1, option 2, option 3. Which one would you like? It's just the sign on the bottom. Then you do 2. Hey, that was a lot of rhyming right there. You do 2. But I'm going to do 3. So 1 minus the cosine of alpha. Alpha is 135 degrees over sine of alpha, which is 135 degrees. Tell me about 135 degrees.
So it's going to go 45.
It's a 45 in quadrant
3, 2.
dos, less than 180, right? So we need the cosine of 45 degrees in quadrant 2. Negative root 2 over 2. So 1 minus negative is going to become 1 plus root 2 over 2 over sine of 135
Sine of 45.
positive root 2 over 2. Oh, you're way ahead of me. Okay, I'll catch up. Times 2. And then Zapparoo, which gives us 2 plus 2 over root 2. Bless you. Rationalize with square root 2. The beauty of having the monomial in the denominator. 2 root 2 plus 2 over 2.
And then cancel the 2.
Lots of 2's.
Root 2 plus 1.
Root 2 plus 1. That was the answer in the book? Wasn't.
They did the first.
They did that?
Yeah.
I'll bet you, if they did it right, that the answer that they got, if you throw it into a decimal, will be the same as the answer that we got. What you could also do is take your calculator. If you're really not, batteries are low, recommended change of batteries. I don't care. Tangent of, mode. I need degrees. Tangent of 67.5 degrees is 2.414. I already know the answer to this. And then the square root of 2 plus 1 equals, and we get exactly the same thing. So, you know what I'm saying? If you're not sure, like if you look at this and go, that's not the answer in the back, plug that into your calculator, plug that into your calculator, and see if you get the same thing. In this case, absolutely got the same thing, so I know we're right. I mean, I was confident anyway, but you know what I mean by that. So, is that okay? Okay. You think they used the top one? And they did something? I like our answer so much better. What did they get as an answer? Was it big and ugly?
Yeah.
Yeah. That's, see, square root of 2 plus 1 is not big and ugly.
So I was gonna ask you, since they got like a reaction like that, is there like, do you have to use a certain tangent equation to use the bottom one every time?
Yep. If, like, let's say I gave you this question on a test, and your answer was not the same as my answer. And by the way, my answer would be this. But you do it, and you get something else. The first thing I'm going to do is look at your work and see what you did. And if you used a different formula, then I'm just gonna follow it through. And if I don't see any mistakes, then what I'll do is exactly what I just did here, is I'll plug your answer into my calculator, I'll plug my answer into my calculator and see if we got the same thing. And if it's all cool, then yeah, I got no problem with that. Yes, sir?
So you won't ever require us to use a certain formula?
Well, I mean, I might say, like, not this one, but this one, we could have used the addition formula, right? Or cosine of 75 degrees, we could have gone cosine of 30 degrees plus 45 degrees. So in that regard, I might say, use the addition formula, or use the half angle formula. But I'm not gonna say, you need to use half angle formula number 2, or anything like that. I'm not gonna say that. Now, that being said, I might give you something like this, like the other problems that you see. I might say something like, what is the sine of, I don't know. So that's, we'll do it this way. What's the sine of 120 degrees over 1 plus the cosine of 120 degrees? Now, you could crank that out, but what I would hope, and I have a better problem than this, but
Yeah, so that's it.
you go, ooh, it's that. So that's going to be the tangent of alpha over 2, but alpha is 120. So therefore, it's the tangent of 120 over 2, which is the tangent of 60, which is square root of 3. So in that way, I'm not telling you which one to use, but I'm giving you this one.
Yeah.
So, does that make sense?
Yeah.
Okay. Any others? We are not going to have any chance of finishing up the chapter today, which therefore means that we will finish it on Monday, review Tuesday, test Wednesday. I know, it was not my plan, but
Wait, this test is
There's
going to be.
better one?
Last time I asked a question like that, we got more.
did you actually get more questions? Or did I just
Yeah.
say I was going to give you more questions?
Never mind.
I know. I'll adjust. I have to adjust. All right.
I think I'm allergic to this, like, in particular. Something
Are we allowed to what?
Something that's not.
Whatever.
Which one?
Yeah.
9 is really nasty and ugly. Did you get something really nasty and ugly?
I tried.
And what they did in the back of the book is they left the radical in the denominator, correct? Because if you tried to rationalize that,
Textbook.
we were doing that first hour today.
Word.
Were you able to get it besides the rationalizing the denominator part?
Do you flip the equation?
I would flip it at the beginning. Because it's cosecant, right? No, it's secant. It's secant, so I basically would take this and flip it right there. And say it's the square root of 2 over 1 plus cosine of alpha. It doesn't make it any prettier. It's really ugly. You have square roots inside square roots, and then you're supposed to rationalize with other square roots. So I know that one, but don't, just kind of plug it in and don't worry too much. I'm not going to go crazy and stuff like that, because I want you to be able to see the formula, use the formula, and be able to adjust things like this. This I feel, wow, you're an angry young man. You should be able to fix this one, but that one, no, that's a pain. So, okay, is that good enough? All right.
It's too sensitive for this.
Is there anybody here that's in mu alpha theta?
I'm not left-handed.
We're supposed to check mu alpha theta Instagram. I'm guessing that that means that they did pretty well at the competition today.
No, it's today.
Yeah, they're at the Cardinal Stadium right now.
Really nice to meet you. Did you do something?
Hey,
Where am I going next?
We're still graphing.
okay. You're writing on yourself?
Yes.
I've gotten in trouble before in class when students have written on themselves during class.
Oh.
So,
Well, I can't tell.
here
I don't
is,
know. It's weird.
here are some of the, wow.
I'm touching the spring in the lab.
Okay, so you like these formulas?
Not really.
Okay. What about these that are in the same section?
I'm good.
We get different ones. Are we gonna get different ones? Is this why you're doing this? You've always said
Product to sum identities and sum to product identities. And so I did a little research, well, I knew anyway. But I talked to the calculus teachers and everything like that, and they all told me, which is what I assumed from when I had taught calc, that there was no need to know all of this stuff, so this is why we're skipping 7-6. So we do not have to do all of this mess. So anyway, that's all I wanted to show you there. We're going to go straight to 7-7. So here's my first question. My first question is this.
Why is this guy?
It isn't.
30 degrees.
What's theta?
30 degrees. 30 degrees.
30 degrees? Or,
Or 60 over 2.
well, 30 degrees is 60 over 2.
Pi over 2.
But I do like or. 30 degrees is pi over 6. Or, I still like or.
Oh. Wait,
2
2.
over 1. 1 over 3?
A coterminal.
What? 150 degrees? 150 degrees. Thank you. 150, where's that coming from? Reference angle is 30 degrees, not coterminal. But it does have a reference angle of 30 degrees, so what? Huh? Quadrant 2, which therefore means sign is positive. So if we had said theta is 30 degrees, or 150 degrees, is that the correct answer? As long as theta is going to be between 0 and 360, our standard one time around. So if theta is going to be between 0 and 360 degrees, then theta is either
30 degrees or 150.
30 degrees or 150 degrees. It is not 210 degrees because
That's quadrant.
it would be negative. It is not 330 degrees because it would be negative. It is not 390 degrees because that would be going around the second time, and that's not what we're talking about. Okay, so you're telling me that in this problem, theta could be either 30 degrees or 150 degrees. Is that correct? All right, let me go back for a second. What question were we answering there? What? Let's not use the word theta. Let's use what?
Is X?
What angle
What angle
is sine?
has
A sine of 1/2.
a sine
Of 1.
of 1/2? Right? That was the question we were answering. What angle has a sine of 1/2? And you said 30 degrees or 150 degrees. Sound right? Good. Let's move on. We've already done that, right? Okay. So we're going to change something up a little bit. We're going to do this.
It's the same question.
What?
It's the same question.
It's the same. It's the same question.
Yeah.
So, what does this mean? What does the -1 mean? It means inverse, and how are we going to phrase that with words?
What size?
What
Or what
angle
Gives us a sine.
gives us a sign of
has a sine of 1/2? Is that the same question we just answered?
Yes.
Yeah. There's one difference though. The answer to this question is 30 degrees. Period.
Is this the reference angle?
It is the only answer to this question. It is very similar in a lot of ways to a question something like this.
X is
Can you solve that for me?
X is 3.
Positive or
Right?
Yeah.
X is 3
Or negative.
or -3, right?
But what's the square root?
Well, what if I asked you that question?
That's just 3.
That's just 3. Same type of thing here, right? If we're trying to solve sine of theta equals 1/2, well, theta could be 30 degrees because sine of 30 degrees is 1/2. And theta could be 150 degrees because sine of 150 degrees is 1/2, right? But when we phrase it this way and we say, what is the inverse sine of 1/2? They're basically saying we're not going to have any options. We just one answer, and kind of like this. So it's the same type of thing, all right? Don't worry, I'm going to get into it all. So you are going to see a lot of this where we're going to start doing this, we're going to use radians a lot. In fact, we'll probably do half radians, half degrees. Over time, you'll see more radians than degrees, but for now, it'll be somewhere in the half-half thing. So if we're asking for radians, what's the inverse sine of 1/2? 5 or 6 is correct. Okay. What is the inverse tangent? And that's the way we phrase it. What's the inverse tangent of the square root of 3?
pi over 3.
Pi over 3.
Pi over 6. So pi over 3. 60.
I'm just letting everybody think it through and make sure that. So you're saying what? 5 or 3? How'd you get that?
60 degrees.
It's on the chart. 60 degrees. 60 degrees is 5 over 3. So we're good. Questions there? What is the inverse cosine of square root of 2 over 2?
Pi over
5 over 4. All chart stuff, right?
So what if it's like inverse cosine of x?
Yeah, we're getting there. That's next. We okay with this? All of this stuff is simply from the chart. Simply from the chart. Okay? We're in radians now. That's the only difference, but the reality is we're just remembering the chart and going from there. All right? Questions on that, specifically right there? Ooh, I got another one for you. What is the inverse secant of 2?
Wait.
5/6. Oh, wait, no, sorry.
Say it again. So this is saying the inverse cosine?
Yeah.
Not the cosine, but the inverse cosine of what?
1/2.
1/2. Are these two questions identical?
Yes.
Yes, they are. I would rather answer the bottom one, 'cause I'm much better at that. So what does that give us?
Pi over 3.
So if we are getting the inverse of one of the reciprocal functions, the inverse secant, inverse cosecant, inverse cotangent, flip what we're getting the inverse of. Okay, take the reciprocal of that, and then it's just this problem. Are we taking the reciprocal of the angle? No, because that is not an angle. That's a value. That's what the secant of theta is equal to. All right, moving right along. It's too easy. Let's make it a lot more difficult.
Sounds fun.
Let's do the inverse sine of negative 1/2. Is that like your instinctive reaction to everything in life, or is it just in math? Okay. Okay, Jake, we're having spaghetti for dinner. Oh, jeez. If you logically had to take a guess at this one, what would you guess? Negative pi over 6?
Does it have to do?
That would be absolutely correct.
Does it have to do with the quadrant?
Does it have to do with quadrant? Would it make sense or not make sense that quadrant would be a part of this? It would make sense. Because remember what this is saying. What angle has a sine of negative 1/2? So for it to become negative 1/2, we have to change the quadrant. Right? What angle has a sine of 1/2? Well, that's a first quadrant angle. But what angle has a sine of negative 1/2 changes the quadrant? To which options? 3 or 4. Okay? What we're going to do, and remember, they're kind of defining some of this stuff over here. So remember that there's only going to be one answer here. So we don't get to decide 3 or 4. The answer is decided for us. And the answer is fourth quadrant. Is that in the fourth quadrant? Yeah? That's in the fourth quadrant. Because instead of going up pi over 6, we're going down pi over 6. So if pi over 6 is in the first quadrant, going up, then negative pi over 6 is in the fourth quadrant, just going down. And so that is the answer.
These are short.
All right. What is the inverse tangent of the negative square root of 3? Negative pi over 3. You got it. So I said it was going to be much tougher, but it's not really, right? So what is the inverse cosine of negative root 2 over 2?
It'd be, negative 5.
Why aren't we just going with negative pi over 4?
So that's 3 in the third quadrant.
Oh, because it's not negative.
Oh, that whole quadrant thing, I got you. What angle has a cosine of negative root 2 over 2. Well, negative pi over 4, like we've been doing for these, negative pi over 4 would be in the fourth quadrant, but in the fourth quadrant, cosine is positive. So that can't be the answer. What are our options for what quadrant this answer should be in?
Go around another time.
And not 1, 2 or 3. Right? Because we're looking for where cosine is negative. And the only places that cosine is negative, quadrants 2 and 3. So once again, we have to, I guess, be told which quadrant we're working with. And when we're dealing with this, we're dealing with quadrant 2. Okay? So quadrant 2. I will explain in a few minutes. But for right now, just accept quadrant 2.
Just for negatives.
Just for negatives and cosine.
Okay, so wait, that means that negative signs are always going to be in quadrant 4? They're always going to be in the same quadrant?
That's why we like sine. We like inverse sine. We like inverse tangent. We don't like inverse cosine so much. Because it's going to be first quadrant or second quadrant. We're going to talk more about that in a minute. But answer this for me if you would. So now we need pi over 4, but instead of being negative pi over 4 in quadrant 4, we need to move it to quadrant 2. And if you remember our whole pi over 4 thingy, we got pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So in the second quadrant, we get 3 pi over 4 would be our answer.
Why would you put, why would you originally try to put negative in the fourth quadrant?
Say that again? Why would you originally try to put?
Negative square root 2 for 2 in quadrant.
Because that's what we did with these. So, like the inverse sine of 1/2 was pi over 6, so the inverse sine of negative 1/2 is negative pi over 6. The inverse tangent of square root of 3 was pi over 3, so the inverse tangent of negative square root of 3 is negative pi over 3.
So
Those are nice and easy.
they're all in quadrant 4 except for those.
Right. And that's because, as you guys said, in the fourth quadrant, cosine's positive. So if we said, can you answer this question for me? Feel free to look at the question. What is the tangent